So we're talking about solving exponential equations, okay? Very important topic in grade 9. Obviously, this is an introduction now. We want to look at this. We will look at this in examples, okay? So we are given an exponential equation and we are being asked to solve for x, okay? We'll look at 1. So what's important, the very first thing that we look to do is to look for bases. We make sure that the bases are the same, okay? So we have to convert this into an exponential equation, and we have to manipulate this in such a way that the base is the same as that, okay? That's what we look for, okay? That's in exponential form already. That's just a number, okay? That's just a number. So what we need to do is, can we convert this number into in an exponential form? Okay, we can, because we know that 9 is 3 to the power 2. Okay, so now voila. So what do we have now? We have two powers of the same base again. Okay, we have two powers of the same base. That's the same base. That's the same base. When that happens, we're gonna drop the bases. Okay, we will drop the bases. When we drop the bases, what are we left with? We're left with 3x is equals to 2. Okay, now it is become an algebraic just equation. Okay, it's just an equation that we've worked with from grade 8 already. Okay, we can divide both sides by 3. Divide both sides by 3, and then we can solve for x is 2 over 3. Okay, very, very, very simple. You see, you get it to that form and suddenly it becomes simple. Okay, let's look at example 2 here. What does example 2 say? Okay, what does example 2 say? Example 2 is 2 to the x minus 4 is equals to 1. Okay, again here we can look at 1. We know this. How can we convert this into exponential form? Okay, this number into exponential form, that's often the first step. Okay, we know that this is 2 to the x minus 4. How do we convert that? We know that anything to the power 0 is 1. So we want this to be 2 to the power 0 is the same as 1. Okay, so once we have that, we look for the same bases again. The key is same base. You see, that's the same base. That's the same base. So then we can drop the bases, and then will be x minus 4 is equals to 0. Okay, so x minus 4 is equals to 0. Now it's an easy equation to solve. X is equals to 4. That is because we just take 4 to the other side and x becomes 4. Okay, let's look at another example. 5 times 5 to the power x is equals to 125. Okay, so let's see here. What do we do here? There's two ways we can do this. Okay, what can we do here? 125. If we had to do 125 is 5 to the power 3 is 125, I think. So if we go here and we go, that's the same base, that's the same base. We can even go 5 is x plus 1. But I mean, it doesn't really matter. We don't have to do that because that's the same base, that's the same base. There's an exponent of 1. And we can convert this into 5 to the power 3. Right. Okay, we've converted that to the power 3. 5 to the power 3. Voila, what do we have? We have the same base again. Same base again. We know what the drill is. When we have the same base, we drop the bases. So we'll have x plus 1 is equals to 3. Therefore, x is equals to 2. Okay, that's example 3. Okay. Let's look at now example 4. Example 4. Okay, no, actually, I want to look at another way I could have done this question. This example 3. So let's write it again. 5 x is equals to 125. Okay. So if I just go 125 divided by 5 here is 25. Okay, so what I want to do is I want to get rid of this here. I can divide both sides by 5. Divide both sides by 5. When I do that, that 5 is going to disappear, right? And I'm going to be left with 5 to the x is equals to 25, right? So now what's 25? 5x is equals to 5 to the power 2, because I'm converting this number again into an exponential form. So now what do I have there? Voila, I've got the same basis again. X is 2, which is exactly the same as that. Okay, so more than one way to do that one. Okay, let's look at one more example. We have 5 to the power x is equals to 1 over 25. Right, okay, this is a bit tricky. Looks like I'm going to have to apply some negative exponents here. We're just going to name it 4. Right, now, if you think about this, 1 is not an issue. And if you look at this here, I can get it to be the same as that. The only thing is, I've got my 25 in the denominator here, okay? So we're going to need to go back there and look at the negative exponents. How do we understand negative exponents to be? So I'm going to go 5 to the x is equals to 1 over 5 to the power 2. Same thing. I've just converted this into an exponential form, okay? So now, what do I do? If I wanted to take that up, I've learned earlier about negative exponents. So I'm going to have 5 to the power x is 5 to the power minus 2. Okay, I've learned that from working with negative exponents. So then I've got same basis. I will have x is equals to minus 2. Okay, that's sorted. That's exponential equation. Just a couple of examples. The more we do the examples, the better we become at this.